Hi, and welcome to this short video demonstration of using Qure. My name is Ami Levin, and I'm DBSophic's CTO. In this short demo, I'd like to show you how you can use Qure to help you optimize your database performance in a very short time. Actually, it's simpler than you might think. There are only two inputs we should prepare before starting the analysis process. First, we need a standard SQL Server trace of the production server activities using the trace template provided by Qure. Qure is a holistic solution which considers all queries for its final recommendations. So, for best results, we highly recommend that you make sure the trace contains as wide as possible range of database activities. You can use traces saved to either a trace file or a SQL Server table. Qure enables you to trace different time periods and use multiple trace sources. The second input that Qure requires is a backup of the production database restored on a dedicated server for the analysis. We recommend that no concurrent activity is performed on the server during the analysis process. It's important to understand that Qure's analysis process automatically applies changes to the analysis database and should never be performed on the production environment. Okay, now that we're ready, let's start optimizing. Let's go for a full analysis. I think I can afford one license for this video. We first need to provide a name for the analysis. This name will be used to create the analysis file, which is in fact a SQL Server Compact Edition database file, which will hold the analysis data and may be shared later with other Qure users. Now, the wizard will guide us through this very complicated analysis setup. All you need to do is provide the connection details for the analysis database, choose the trace files or tables you've prepared in advance. We'll leave the additional option settings at their defaults for now, and we're ready to go. From here on, everything is done automatically by Qure. Told you it was complicated. Once the analysis phase completes, Qure provides us with a summary of the analysis process and its results. Here, on the summary page, we can view the full details of the top 10 improved batches. We can also see how many recommendations Qure has generated in each category and the estimated impact of applying these recommendations on a rough scale of 1 to 5 stars, and general information about the analysis process itself. Let's begin by examining batches and recommendations. A batch represents multiple execution of a set of one or more queries excluding parameter values. Note that Qure uses the word value, highlighted, as a placeholder for reference where the actual values were removed from the batch. Furthermore, Qure enables you to drill down to specific parameter value sets to quickly pinpoint anomalies. Qure provides 4 different views for its performance metrics. The original production metric is as read from the production server trace, the metrics of the analysis database before applying recommendations, after applying recommendations, and a special view that shows the total actual improvement of the batch's resource consumption, the optimization result tab, which is selected by default. In the bottom pane, for each batch, Qure provides the performance metrics in full detail and graphics, the original batch script, potentially with the actual parameter values, an overview of the database operations performed by the batch, and a tree view of links to all associated recommendations that will optimize this batch's performance. An alternative way to view the recommendations is in the scope of a specific object instead of the scope of a batch. This can be done by using the Objects page. This page allows you to easily drill up and down the object dependency and evaluate the full potential scope of applying any recommendation. The information is derived from Qure's internal parsing and not from the database dependency lists, which may be incomplete. So, let's go to the actual recommendations. We can use the various link levels to navigate to any subset of the recommendations by category. Let's say we want to view all recommendations associated with this specific batch, so we'll just use the root link. On the recommendations page, we can view the actual recommendations in detail. Since we use the navigational links from the batches window, the filter settings are automatically applied to help us focus on the relevant subset of recommendations associated with this batch. If we want to view all recommendations, we can simply clear all filter settings. Let's dig a bit deeper into the recommendations. As you can see, recommendations are grouped by category and arranged as tabs. Every recommendation includes a detailed description of its nature, impact, and scope. For example, each missing index recommendation details all objects and batches that may be affected by it. Qure doesn't just add more indexes, but it may recommend replacing existing indexes and dropping of redundant, duplicate, or ineffective ones. Of course, Qure automatically generates the required scripts for these recommendations, which can be copied or saved to file. Qure always provides both apply and revert scripts in case you want to undo the changes quickly. Let's take a closer look at a few rewrite recommendations. Qure rewrites deal with a few aspects of query syntax. For example, rewrites that may enable more efficient index usage, such as automatically rewriting search predicate to exposed search columns. In this example, you can see how the predicate that used the last updated column, which was used within the dateDiff function, is rewritten in reverse logic to enable index usage. Other rewrites deal with compilations and efficient parameter evaluations. In this example, a subquery is used in a search predicate. Since the actual value returned from this subquery is unknown at compile time, the optimizer may generate a suboptimal plan for it. The suggested rewrite declares a variable, populates it with the actual value returned from the subquery, and then passes it for explicit compilation as a parameter for SP execute SQL. This may enable the optimizer to produce an optimal plan for this query. Qure has many more types of highly efficient rewrites in stock for your queries and objects. Schema recommendations may include adding or dropping constraints, changing column and table properties, re-enabling untrusted objects, and many others. For example, untrusted constraints, which are ignored by the query optimizer and may lead to less than optimal execution plans, potentially missing not null constraints that may significantly help the optimizer evaluate queries more efficiently, and many other surprises. Some of these recommendations are actually very easy to apply and highly effective. In addition, Qure provides you with many so-called miscellaneous recommendations. These will, in most cases, require manual investigation since they cannot be automatically corrected. These may include general database and instance issues, object property issues, maintenance issues, query and technique used, such as select star, hints usage, missing join predicates, and many others. Most of these recommendations are not benchmarked but may lead to substantial performance improvement when corrected. So, what do we do with all this information? Where do I begin? Let me show you how easy it is. All you need to do is identify the batches you want to optimize. You can select batches which are of high priority to you, or simply sort and select the top improved batches by any performance metric which you know to be a bottleneck for your system, such as physical reads, writes, or CPU. Then, use the provided link to all recommendations associated with the selected batches. Go to the script preview and save the script to file. And then, from there, it's just a matter of QA and on to production. It is that simple. Thank you for watching this video demonstration, and please don't hesitate to contact DBSophic with any issue or question regarding Qure. Thank you for your time.